Welcome to SAT School. I am your instructor from satschool.com. This is our third video on HCF and LCM. Now let's get started. This is practice question number 10 that we left on last video. If you have not watched that video, I strongly recommend to watch that first. Click the I button above and watch the video. And I hope you should have managed this. If not, follow me. Here the first expression is x plus 1 whole square, which is in the form of a plus b whole square, and that can be written as x plus 1, x plus 1. The second expression here is x square minus 1, which is in the form of a square minus b square. So that can be written as x plus 1 and x minus 1. And the third expression is x square plus 4x plus 3. So we have to factorize this expression. To factorize, we multiply the constant. Here the constant is 3 and the coefficient of x square. Here the coefficient of x square is 1. So if you multiply 3 and 1, that gives 3. Now the factors of 3 are 3 and 1. And that helps to get us 4x. So that can be written as now x square plus 3x plus x plus 3. So the 3x and x are obtained from factors of 3. Now the first two terms, in the first two terms we have x as a common. So if x is common, that gives x plus 3. In the last two terms we have 1 common. So if 1 is common, then x plus 3. Now two factors are x plus 3 and x plus 1. To find out HCF, we have to look at the common factor. In this case, we have x plus 1 common in all those expressions. So here HCF is equals to x plus 1. Now remaining factors from the first expression is x plus 1. The remaining factor in the second expression is x minus 1, and the remaining factor in the third expression is x plus 3. So the LCM is x plus 1, the common factor, and all remaining factors. Now this can be written as x plus 1 whole square, x minus 1, and x plus 3. So this is the HCF and LCM. Now next practice question number 11. Here the first expression we have a4 plus a cube minus a square minus 1. If you look at all those terms, we have a is common. So here a is common among those terms. If a is common, that gives a cube plus a square minus a minus 1. Now again looking at first two terms, inside that a cube plus a square, here a square is common. So that can be written as now a square a plus 1. Looking at last two terms, we have minus 1 common, and that gives a plus 1, which can be written as a plus 1, a square minus 1. Now a square minus 1 is in the form of a square minus b square. So that gives us a plus 1, and again a plus 1, a minus 1. That is from a square minus 1. Now the second expression is a4 minus a. Again here a is common. So if a is common, now that gives a cube minus 1, which is in the form of a cube minus b cube. And we have the formula for a cube minus b cube is a minus 1. Here a square plus a plus 1. So that is in the form of a cube minus b cube. Now finally we have 4a square minus 4. Again 4 is common. That gives you 4a square minus 1, which is in the form of a square minus b square. Can be written as now 4a minus 1, a plus 1. Now the common factor among three expressions is here a minus 1, and that is the highest common factor between or among them. So HCF is now a minus 1. Now this is practice question number 12. The first expression here is in the form of a4 plus a square b square plus b4. So we have to factorize the first expression. Again, that is in the form of a4 plus a square b square plus b4. Now to factorize, we change m4 into m square whole square and n4 into n square whole square. Now here m square minus m square n square is from the given expression. The next m square n square is added, and again that is subtracted at the end. That is m square n square is added as well as subtracted. Now the region is, now we can change that into a square plus 2ab plus b square, m square whole square plus we have 2m square n square, that gives you 2m square n square. Again n square whole square and the last term m square n square. Now the first three terms, that is in the form of a square plus 2ab plus b square, which can be written as m square plus n square whole square. Again the last term now can be changed into b square, that is mn whole square. Now this is in the form of a square minus b square, and we know that is equals to a plus b, a minus b. So you can arrange that m square plus mn plus n square, or m square minus mn plus n square. The second expression is m square n cube plus m5. We have m square common between two terms. Now if m square is common, that gives you n cube plus m cube, which is in the form of a cube plus b cube. So the formula for a cube plus b cube is a plus b, a square minus ab plus b square. Now looking at two expressions, we have n. Now you can arrange that simply, that is m square minus mn plus n. And looking at two terms, we have a common factor, which is m square plus mn plus n square, and that is the highest common factor. This is a practice question 13. The first expression is x cube plus 1, which is in the form of a cube plus b cube. And my bad, this is the first expression is x cube plus 1 plus 2x squared plus 2x. So you look for two terms. The first two terms, x cube plus 1 is in the form of a cube plus b cube. The last two terms, there is 2x is common. And looking at second expression, we have x cube minus 1, which is in the form of a cube minus b cube. And finally, we have x4 plus x square plus 1. And that is in the form of a4 plus a square b square plus b4. And that is what we did in practice question number 12. So I want you to practice this question, and I hope you can manage this. Thanks for watching. If you like the video, don't forget to subscribe. I will meet you in next video. Take care.